Welcome to the DIY3DTech.com channel.
Welcome to this edition of DIY3DTech.com. In this episode we're going to follow up on the building the laser cutter. So basically we've got some of the basics put together, so let's kind of walk through this a little bit. So we have the belts inserted. You see we've left a little bit extra here so we can tension them. The belt tensioning is good, so we have it both on the y-axis as well as the x-axis. That's actually the front of the machine there. This is going to be the back of the machine. This is our 12-volt power supply. You probably remember this from a previous video where we walked through setting up the board. So we now have the we have the y-axis clone. We have it hooked up. We have the power running. We've got it now hooked up to the universal G-code sender. So let's make some motion here. So let's see how this goes. So as you can see, I'm just controlling it from the universal G-code sender, just making it move back and forth. And you can see the axes work. Yeah, actually does pretty good. So far I'm very happy with it. I haven't configured Gerbil yet for the exact settings. Again, just wanted to see how everything is working. It's working. I have to engage micro-stepping yet on the board here. I do have the cloning, so the cloning does work. The power supply works. The motor and general configuration work. The y-axes are aligned. The x-axes work. Everything's tensioned down good. So a very good start. So when I get some more time, I'm going to actually work on creating some of the mounting hardware for this, finish up the configurations between the two, and we should have a working machine here in a couple more episodes. A couple build notes I did want to mention. On the underside here, one of the things that hopefully you can see, I installed the the pulleys or the gears upside down, or what would normally be upside down, as they aligned better, and also the shafts on the motors are slotted, so this allowed me to actually put one of the set screws into the slot, locking that motor in place. So that really worked well. So that was just kind of a nifty little tip to use. And again, you probably saw in the last video, if you've been following along, the configurations. Board works great. I'll put some links down below for matching board if you want to build the same. So far this whole project has turned out really well. So if you go back in the history of this, you can see I've got the basic design from the Open Builds website. Went through, bought some of the maker rails. I think a very good configuration. I like the size. I've gone 500 by 500 millimeter. So roughly it should give me about an 18 by 18 inch working area. So I can do t-shirts, I can do larger material, which is really what I wanted to be able to do. Good 12 by 12 type stuff in this working area. I'm going to have a base. Also, this stuff will be mounted in the back. One of the things that I did realize after doing this is I actually show you. So I'm going to have to do a little bit of design changes. However, if I push this all the way back, notice that this motor actually sticks past the back. My original plan was actually to mount this as such. And you can probably see the motor is going to hit it far before the end. And even though it's going to be end stops back here, located back here, that's kind of close, and that's going to take away, I think, too much to do that. So I'm going to probably do something flat on back here to mount both of these to it, and put some kind of base board. I don't know. I'm thinking that I'm going to make it a large piece of acrylic and cut it to the size, mount this to the acrylic, and then just have the acrylic hang out about this distance, because as you can see, the motor from a height-wise here easily clears this. The electronics, no big deal. The only other electronics is going to be a laser driver board, which is tiny, so there's going to be plenty of room the width of this back here. I am going to probably build something that goes across the sides to duct smoke. I thought about mounting something up here. If you've probably seen on the CNC where I've got the laser mounted now, I'm using the dust pickup, kind of suck up the smoke. This is kind of a lightweight for that, and I'm not sure I want to be dragging around a hose or have that whole thing here. So one of the things I'm thinking about doing, and I have to experiment with it, is put a fan maybe in the center here, down here, and take a piece of plexiglass. I'll lift this up. Mount the plexiglass to these holes and here, so it runs across this section, clearing this rail in this wheels, and then mount the fan to the plexiglass, and then have that exhausted, and put a little duct here so I can hook it to like an 1.5-inch tube, because I'm going to build about an 1.5-inch vent system into my workshop for the different laser projects, because I'm going to do another one too. And so that's what I'm thinking. And then what will happen is the fan will draw the fumes across downward, and I may even build over time an enclosure for this. Not sure yet. Depends how it goes or how interested I stay in this and use this. So far I've been having a lot of fun with the laser on the CNC machine. So I think there'll be more to this, and I've ordered actually another smaller laser to experiment with. And I'll be doing some videos on that, but so far I'm actually very excited the way this is working. The other piece is that the tension here is pretty good for this just being plastic and that. So not quite up to what I'd call, if I was pushing a CNC mill head around, it's probably has a little bit too much give for that. Because the torque this would be pushing, but not bad. And if I went with metal plates, I think it would actually be very good, because I'm also thinking about redoing my CNC router. It's about 5 years old, made out of MDF and PVC and that kind of stuff, kind of like a first generation robotic fireball, which is actually okay for most of the stuff I use it for, but this is I think quite a bit more sexy looking and etc. and kind of interesting. So I got the motors and the electronics, so basically all I need to do is build this pinion, basically setup, or linear motion setup. So anyways, hopefully this helps. We're making some pretty good progress on the laser build. There'll probably be one more video that I'll do after I have all this kind of cleaned up and tucked together and configured, before I actually put the laser on and have it cutting, and then we'll probably do the final video with it all coming together. So again, let me know in the comments below if you're interested in this. I'm thinking about maybe doing some kits of some of the pieces. Again, most of it's pretty open source. However, I'm thinking about bundling together the kits. I have some pretty good prices on the power supplies and the boards out of China, and especially if I buy in bulk, I can get them even cheaper, as well as the motors, and then do a pre-printed package of all the parts. I've got a couple pretty good sized 3D printers. I can knock out the pieces pretty quick, and so if you don't have a 3D printer, or you have a smaller one, knock it out. I'm also thinking, if you've seen some of my other videos, changing the wheels out in a future version for the skate bearings. Again, the metal against aluminum, steel against aluminum isn't ideal, but I've also come up with that other wheel. Now it'd be a little bit larger, but again, I think keeping the cost down, because right now I think with the basic build in this configuration with the laser, I'm going to probably be about $300 all in to get this set up. I think if I were to do a kit, I could probably get the cost down, because again, buying the components in bulk and having done one now, I know how to optimize it. Because one of the big things there, actually the wheels are very expensive. They're about $5 a piece. Yeah, so you're looking at 20, 40, 60 bucks just in the wheels alone. The actual maker rail is actually pretty economical, and so is the electronics. So I think I could get it down. And then also, the laser is the other expensive item, and I can get a nice 3-watt out of China for $150, power supply, driver, whole 9 yards. So I think that'll work out really good. Because the other piece I have to do here is, when I do the laser driver, hook up the spindle controls and probably add an extra relay. I'm not sure how I'm going to handle that yet. If you've seen the videos I'm doing on the CNC, I'm using a SainSmart relay board and then also using spindle speed control for the TTL output. And when I get to that part of wiring up the laser, I'll probably do an extended video on that also to help you folks. I'm also thinking about, if you're interested, doing a video on lasers in general. Basically what I've learned is quite a bit on lasers, and definitely not all lasers are created equal. And even if you go and get a 2-watt laser, it probably won't do much better than a 500 milliwatt laser. So if you're interested, please leave me some comments below. I'd be happy to do a video on it, kind of walk you through. Like I say, I do have a couple other lasers on order to test, so I'll do some comparisons in the near future and set it up, because I'm thinking about also building a smaller version of this on the Mantis 9 design, just for grins and giggles. So anyways, please like below. Like is simple to do. It helps us create more videos just by you clicking that like button, because we get more exposure on YouTube, which drives more traffic, etc. So just that one little click really helps us out. If you're interested in this kind of stuff, subscribe to the channel. I think at this portion of this video we've put out about 80 videos or so already. We try to really kick out the videos. Our goal is to get not so much to be YouTube talking heads, but to inspire our viewers into building, into making, into desktop fabrication. So again, that's our real goal here. So by clicking the like button and subscribing to the channel, you really help us out. So not asking for any money, just a simple click. Cheers, and we'll see you in the next video.